Hello and welcome to our virtual Lunch and Learn today. We will be talking about smart motor control. My name is Rachel Green and I'm the Digital Communications Specialist here at McNaughton-McKay Electric Company. And presenting for us today are Travis Dixon and Daniel Smith, automation consultants out of our New Bern, North Carolina location. Out in the comment section, ready to answer your questions today is Gino Porter, automation specialist out of our Charleston, South Carolina location. We will also have a Q&A portion at the end for Travis and Daniel to answer your questions in more depth. We'll be getting started shortly. We would like to allow a few minutes for attendees to join us. As you come in today, let us know where you're joining us from in the comment section. You can view recordings of previous virtual Lunch and Learns on our YouTube channel under the Virtual Lunch and Learn playlist. We cover a new topic every Wednesday at noon, so be sure to join us on your lunch break. For anyone just coming in, welcome to our virtual Lunch and Learn Smart Motor Control. Let us know where you're joining us from in the comments section. We'll be looking for questions as you have them, while our presenters, Travis and Daniel, review Allen Bradley's offering in the smart motor control space. And our specialist, Gino Porter, is ready to respond to any questions you have. If you'd like to reach out afterwards, or if you have further questions for Travis or Daniel, you can send us an email at macandmaclive@macandmac.com. Be sure to let us know which session you attended, and we'll direct your questions to them. We'll also have that email address at the screen at the end of their presentation as well. All right, we have a number of viewers with us now, so I will pass it over to you, Daniel.
All righty, thank you. Good afternoon, everyone. My name is Daniel Smith. I'm the drive specialist with McNaughton-McKay in New Bern, North Carolina. And today we want to talk about our drives portfolio. The PowerFlex drives are broken out into what we like to call two classes. We have our component class drive or compact class drives, which is the 4 series drives and the 520 series drives. And then we have our architectural class drives, which is the 7 series and 750 series drives. This slide here is just a real quick 30,000 foot view of one of our 4 class drives, which is the 4M, and our 520 series drives, which is the 523, the 525, and the 527. Go to the next slide, Travis. So our 4M series drive is, an ideal drive for machine level drives, standalone applications. They're very compact, very easy to use. They're just strictly a volts per hertz drive. They're the ideal applications for them are fans and pumps and small conveyors. They are used a lot of times just to replace cross the line starters. As you can see in the photo on the right, this is the only drive that we have this natively has top feed in and bottom feed out, which makes it real simple to use in the case of a motor starter, and also replacing the Bulletin 160 drives that I know a lot of you plants have. Next slide. Our 520 series drive is our entry-level drive in the 520 series class drives. This drive you can get in single phase all the way up to 600 volt 3-phase. It goes from fractional horsepower all the way up to 30 horsepower. It has a modular design, meaning that the power structure in all the 520 series drives are identical. The only thing that's different is the control module, and that's what distinguishes whether it's a 523 or 525 or 527. They all have the ability.
I'm sorry to interrupt. Travis, could you mute for us? We're picking up some background noise on your mic, and we keep seeing your video. Awesome. Sorry, Daniel. You go right ahead.
No worries. So the 520, all the 520 series drives have the ability to be able to be configured offline, meaning that say a maintenance guy can be installing the power structure out in the field, and an engineer can plug into the control module of the drive and program it via just a USB printer cable. This drive is easily programmed using the free Connected Components Workbench software that Rockwell offers to everyone. It's an unlicensed software, and it talks to all PowerFlex drives, from the low voltage drives as we're talking about here and the medium voltage. The 523 drive has a premier integration platform. Rockwell has designed an AOP that you can download to pull all the tags and the logics and get all that information needed. The 520 series drive is the smallest in class of anybody else's drives. It also has the highest temperature rating. Straight out of the box, all the 520 series drives are rated to 124 degrees Fahrenheit, I believe. And then if you add the little external fan and do a little bit of derating, it goes all the way up to 156 degrees. Next slide. So our 525 drives, you can see it looks identical to the 523 like we spoke about earlier. Just if the picture wasn't a little grainy, you'd see it just says 525 on the front. The biggest difference between the 523 and the 525 is the 525 has embedded Ethernet and also embedded safe torque off. So right out of the box, it is able to be put on an Ethernet network, just integrate in with a Logix environment, and then wire in hardwire safety controls. Also, the difference in the 525 is it has more motor controls. It's also it does volts per hertz, sensorless vector, as well as running permanent magnet motors. And again, the power rating is the same. It goes from fractional horsepower all the way up to 30 horsepower. Next slide. Oh, I think we skipped one, Travis. Or maybe that slide's missing. Well, one drive I didn't talk about, back up one more, please. The 527 drive, again, looks just like this. The biggest difference between the 527 drive and the 523 and the 525 is it is not a standalone drive. It is only controlled via Ethernet, and it has to be integrated in with a compound Logix or control Logix platform. The motor ratings, horsepower ratings, and temperature ratings are all the same as the other 520 series drive. Next slide, Travis. So now we're getting into our architectural class drives, and as you can see from the picture a little bit, these drives can and are significantly larger than the component class drives. Let's go to the next slide here, Travis. So our entry level architectural class drive is the PowerFlex 753. It is available from 1 horsepower all the way to, this slide is actually wrong. It goes to 400 horsepower now, not 350, which is a 477 amp drive. It comes with a little bit of I/O. It has 2 digital inputs, 1 digital output, 1 analog in and 1 analog out on the main control board. There's also 3 additional ports embedded in this drive where you can add more I/O or safety cards or communications cards. So if you wanted to put this drive on Ethernet, it has a native Ethernet card that allows you just to integrate it in with the control Logix platform seamlessly. Another big addition to the 750 series drives is the built-in device Logix. The device Logix is great in a lot of standalone applications where if you have a drive that needs to do some control, but you don't want to invest in a small PLC, 750 series drives has a built-in PLC in it, a small PLC. It can look at levels and analog signals and write some code just like if you were writing ladder logic or function block in a control Logix platform and have the drive do some controlling for you. Next slide. So our 755 drive looks up to 400 horsepower, looks identical to the 753 drive. The power structure is identical. The only difference is the main control board, or what I like to call the brains of the drive. One other feature that a 755 has is, when we spoke earlier about the 753 drive having 3 additional ports, the 755 has 5 additional ports. Also has embedded Ethernet, so we can has the ability to add more option cards for additional I/O, safe torque off, and safe speed, and also for whatever reason if you needed additional communications. It also has the ability to do what we call torque proving. This is mainly used in lifting and hoisting applications, where if you were picking up something and you were having a mechanical brake hold it, the drive checks to make sure that the brake has it before it lets go of torque and lets go of it, so that you don't have to worry about dropping a load and damaging something or hurting someone. The 755 drive has a horsepower rating from a half a horsepower all the way up to 2,000 horsepower. Next slide. So now we're getting into our newest 755 offering, which is the 755T drive. There's actually 3 different 755T drives: the TL, the TR, and the TM. The TL drive is just a low harmonics drive with an active front end. It does not have the ability to do any regenning back to the grid. But as all 3 of the drives, it has the ability to do true predictive maintenance, meaning that there are some algorithms written into the drive where it looks at component usage and load of how much is being used, and it can predict when it might fail, and give you a warning stating that this power component needs to be changed before failure. This fan needs to be changed before failure, and then that way you can schedule downtime and have these maintenance things taken care of instead of running to failure and losing downtime. It's also very compact in design. The motor cables, when replacing an inverter or a converter, you don't have to unwire the motor to replace those components. They slide right out, and all your terminations stay in place. Our 755 TR drive is a regenerative drive. Those drives are used a lot in winding applications. There's a fair amount of them now on paper machines, where they're sharing load and doing load sharing. They also have the ability to do what we call adaptive tuning. So if you're running a big paper spool, and as the paper is unwinding or winding and the inertia and the load changes, the drive has the ability to adapt to this on the fly, which used to take lots of code writing and engineering time, and now it's all integrated in with the drive. The 755 TM is for multiple drives. It's kind of like to refer to it as a large power supply. We actually end up hanging more 755s off of it. This is used as well as a lot of times in paper and steel industries, where they're doing a lot of load sharing and that kind of thing. Next slide. And this is not last but not least by any means, in the 7 class series drive is our PowerFlex 70 drive. This platform has been around for a few years now. It's a very compact drive to be an architectural class drive. It ranges from fractional horsepower up to 50 horsepower. It is our only architectural class drive that we can get in the IP66 or NEMA 4X enclosure, and it's self-contained. It is also integratable with Logix over Ethernet by adding Ethernet card to it. And again, there's a add-on profile that Rockwell has designed where you can pull all those tags and everything for it into Logix. Next slide. Our PowerFlex DC drives is taking the place of the old Reliance DC drives that were back in the day. This drive, a standard drive, out of what I call out of the box brown box drive, is up to 570 amps. We have the ability to do up custom drives up to 6,000 horsepower. The I/O, it has onboard I/O for discrete inputs and outputs. There's already a built-in Ethernet encoder. Encoder, not Ethernet encoder. That's embedded in the drive. We're able to add control comms cards to drive to talk to drive. I can't talk now. But the drive can talk with control logics or compact logics over Ethernet. And it's also a drive that can be used on a network or in standalone applications. This drive comes in two flavors. There's a 2-quadrant drive and a 4-quadrant drive. The 2-quadrant doesn't have regenerative capabilities, where a 4-quadrant drive has the ability to regen that overloaded hull and put it back on the grid. Next slide. So now is what we're looking at is the Rockwell's medium voltage drives platform, which is the PowerFlex 6000 and the PowerFlex 7000. The PowerFlex 6000 is Rockwell's newest offering in the medium voltage world. It is a cascaded H-bridge drive, meaning that it is voltage sourced, kind of works very similar to a low voltage drive. It has a phase shifting transformer on the front of it that gives it the low harmonics. It is a 2-quadrant drive, so it doesn't have the ability to do any kind of regen. It's mainly for induction motors only. Can run cable lengths up to about 2,000 feet. Its design inherently makes it low harmonics. It's also in the medium voltage drive world has the smallest footprint of any of the other drives. And it has a rating from 2,300 volts all the way up to 11 kV, and you can get up to 680 amps. Our second drive, which is the PowerFlex 7000 platform, and this platform has been around for a few years now, and it's just been a robust platform, and we like to consider this our special purpose drive, and it has a rating up to 6.6 kV, 2,300 volts all the way up to 6.6, and an amp rating of 720 amps. This drive is a current source drive, which makes it a little different than the PowerFlex 6000. You can get it in a liquid cooled option or an air cooled option. Because of it does not have a pulse width modulated output like other drives. The signal that comes off of it is a sinusoidal signal and can run cable lengths up to 30 kilometers. Also has the ability of running induction motors and synchronous motors. And as far as an induction motor, it doesn't have to be an inverter rated motor because it doesn't have that pulse width modulated signal. It inherently is able to regen, so you can do regenerative braking without having to do brake resistors. You just dump that excess voltage back out to the grid. And also has the ability, just like the 6000, of being on our Logix platform over Ethernet. Next slide. Now I'll pass the torch to you, Travis.
Thank you, Daniel. My name is Travis Dixon with Coastal McNaughton-McKay. I'm the IC Sensor and Safety Specialist. I want to thank you for your time today. I'll be going over the SMC Soft Start family offering through Rockwell for Allen Bradley. Starting with our SMC3, it's a dip switch configurable with internal bypass. You set your full load amps by a rotary dial right on the front of the unit. It also has a LED that gives you run status, fault type, and if the unit is off. Next, we have the SMC Flex, which is more of our middle of the road, modular by design for installation and commissioning. Features a built-in LCD display, flexible communications, provided advanced performance, diagnostics, and protection. It also is, what it means by modular by design is the control module and the internal bypass contactors can be replaced individually. So versus having to buy a complete new unit, you can replace parts and pieces individually. As far as communication, it offers several different communication modules. Some of the main ones are Ethernet, device net, control net. So if later down the road you wanted to go from a control net communication to an Ethernet, you would simply just replace a card. Let's see. Next, which I want to spend a little more time on, is our SMC 50 offering. It's offered with a integrated bypass, just like the SMC Flex, or a solid state structure. So it combines the power structure of the SMC Flex with the application flexibility of the SMC 50. So let's dive into that. So SMC 50 scalability, that's one of the many strengths of both the internal bypass and solid state SMC 50. Some of the scalability examples, normal and heavy duty thermal ratings. You can select if you want an internal bypass, which is really focused more around standard applications, fans, pumps, conveyors, heat sensitive applications, or a solid state structure, which is really for demanding applications like crushers, shredders, shock loads, a high duty cycle. It's a lot more rated for dirt and debris. You can also use an external bypass with the solid state version, if you prefer that. Also, you can have up to 3 digital analog ground fault current sensing or PTC modules, multiple programming methods via HIM, connected potent workbench, Studio 5000 within an AOP. It's also programmable by what's called a PCM card, which is a card for the SMC 50 that makes it dip switch configurable. So, and that built-in modularity allows for simple user field modifications. Like the example I used for the SMC Flex. If you wanted to upgrade communications, it's very easily done in the field. Some of the starting modes. One of the main that's very important for the SMC 50 is the centerless linear acceleration. It's a patented unique feature to the SMC 50. We'll go in more in depth in all these individually here in a second. The enhanced slow speed is also very important. You can run it from a 1 to 15% of the full motor speed in 1% increments. And you can do that both forward and reverse without a reversing contactor. So for example, if you have a 1800 RPM motor, that slow speed operation can be plus or minus, down to 270 RPMs. Torque control is also new. Also, what is included is all the traditional start modes with the SMC Flex and SMC 50. This is an example of the linear acceleration versus a pump start. Sensorless acceleration, like I said, was that patented unique feature. There's no external feedback needed with this. It provides exact motor acceleration control under varying load conditions, much like a drive. There's only 2 parameters there to configure. You use a minimum amount of energy needed to accelerate the motor and the time requested. Smoother torque than other starting modes, definitely much versus a pump start. You can see in the diagram. Also, the sensorless linear acceleration will give you the closest start time to what's programmed versus all other methods. Next is the enhanced slow speed, which is also another patented mode. It's also programmable in 1% increments. You can do the slow speed as well and forward and reverse without a reversing contactor. And it's kind of one of the shining points of the SMC 50 because it's got very good slow speed torque, you know, unlike competitors or even the SMC Flex. You can also do 2 programmable slow speed references. You can switch in operation between slow speed 1 and slow speed 2 with a terminal input. You know, it's used for positioning, maintenance, alignment, you know, aligning a bandsaw or a loaded versus unloaded conveyor, rock crusher, some of that. And your kind of limiting factors there is obviously the thermal capacity of the motor and the starter, and whatever additional requirements of the motor branch supply. Transitioning into SMC 50 stopping modes. This is both for the internal bypass and solid state units, is the centralist deceleration, external braking control, and all the traditional stopping modes. The centralist linear deceleration is also a patented mode specific for the SMC 50. So this is some of the additional modes of operations you get with the SMC 50. Motor winding heater is really, it's used to heat the motor winding so that condensation develops on the outside of the motor and not the inside. The energy saver mode is used, you use 2 power monitoring parameters to detect when the motor is lightly loaded, and it phases back the motor terminal voltage to save energy. Emergency run, if you want to disable all faults and just run it. It's really great for critical applications where continued operation of the process is the most important issue. The resistive heating is for solid state units only. It allows linear control of output voltage from 1 to 100% for loads like autoclave, a fluid bath, some types of lighting, you know, resistive loads. Another key features of the SMC 50 is advanced diagnostics that are offered with it. You know, power consumption is a critical characteristic of every application. So, and if you can't track it, you can't manage it more efficiently. It enhances application problem solving and troubleshooting. And it kind of eliminates, in other instances where you would need a power monitor, it eliminates the need for that because it offers the same data in one form factor. These are some of the parameters allowed monitoring of many power properties that have historically only been found in traditional power monitoring and hardware. This, used in conjunction with a built-in device logic engine, command and control decisions can be made locally based on changing power and load conditions. This is the frame sizes offered for the internal bypass and solid state units. Anywhere from 108 amps to 480 amps for line connected motors, and from 187 amps to 831 amps for delta connected motors for the internal bypass. And it's kind of really geared more towards the replacement for the SMC Flex, you know, later on down the road, when this is kind of going to be the foot forward of the SMC 50. For the solid state power structure, we can get it down from a 90 amps on up to 520 amps for line connected motors, and from 155 amps to 900 amps for delta connected motors. And if you have any existing SMC Dialog Pluses out there, this is kind of Rockwell's recommendation forward, is to go with the solid state SMC 50. And also is the common control module to both the internal bypass and external bypass, and solid state, excuse me. You can get it with a 100 to 240 volt AC supply or 24 volt DC. You get your onboard control IO, 2 configurable 24 volt DC inputs with integrated 24-volt DC power supply, and you get 2 configurable relay outs that are rated up to 5 amps. You also get the expandable I/O slots up to three cards, and all the different communications modules associated with that. And one of the something big that's often overlooked is the conformal coating. You know, it's a lot more durable, a lot more resistant to oils and gases getting into it, so a lot better. So just to kind of wrap things up, true 3-phase control that equals superior performance. Also, the simple to advanced fault power monitoring, that's a key factor in the SMC 50. The ability to see your diagnostics accuracy and time stamping, snapshots of what's happened with your SMC, is highly configurable. Also, the high fault SCCR ratings with standard breakers, non-traditional. It'll fit great with non-traditional applications. You know, transformer, linear induction, resistive heating applications, and also the ability to mitigate, you know, having to have additional power monitors, scopes, ETMs, motor winding heaters, or a DC brake. And that is all I got. If I could pass it back to you, Rachel.
Great, thank you, Travis. We did have a couple of questions here, which Gino has been answering in the comment section, but I wanted to just read the first one out to you guys, see if you wanted to add anything additionally. Nabil asks, difference between 2 identical horsepower VFDs but have different output current. Gino did answer and said that the different manufacturers use different power components, and different power components yield different current output capabilities, but I wasn't sure if you wanted to add anything additional to that.
No, I was trying to find the unmute button.
Oh, sorry.
My bad. I was looking in the wrong place. And I think Gino was spot on. You know, different manufacturers use different components and rate things in different ways. A lot of it also could be if it's a heavy duty drive versus a normal duty drive, that would change the amp rating possibly, most likely. But I think Gino's spot on with his response.
Okay, great. And then he went on to ask a question about a motor that was particular to his application, and Gino did provide a publication for him to check out, and it looks like he got his answer there. If anyone watching this recording has any further questions, you can always reach out to us at email address on the screen, macandmaclive@macandmac.com, and Daniel or Travis can reach out to you directly with answers. We'll also just give a couple of seconds here at the end if you have any follow-up questions for either of them. And I'd like to thank Travis and Daniel for this wonderful presentation today. And thank you to Gino for being our resource out in the comment section. Does not look like we have any follow-up questions at this time. So with that, I'd like to encourage you to subscribe to our channel for more industry content like this. And please join us again next week for our next virtual Lunch and Learn. We will see you all live again soon. Thank you, everyone.
Thanks.